resource and person in the community, and so glad that he's able to teach the workshop for today. So with that, I'm going to pass it over to Ryan, and we will kick off the workshop for today.
Awesome. Thanks, Phil, and thanks for the nice jams to get things started. Always a great way to kick off some workshops here. So for those that I have not met, and I'm actually just scanning the Zoom room here, I see a lot of familiar names, so it's good to see some familiar folks here on the line. But for those that I have not met, my name is Ryan Johnson, as Phil mentioned. I'm a customer success manager here at RStudio, and I do work a lot with various healthcare, pharma groups, and I'm really excited today to be presenting on a topic that's, I guarantee, has never been presented at RM Pharma before, because it is new as of 3 or so months ago. And that is developing Shiny applications using Python. So I'm going to go ahead and share my screen now, and we'll get things going. All right, so Shiny for Python. Probably the only housekeeping thing I'll have here is that the slides for today, they should be posted into the chat, and it's really important that everybody has those slides open up on their computer. For all of the interactive components of today's workshop, there will be links that you'll click on, and that will basically open up the environment for which you'll be doing work in. So just make sure you have those slides there, and if there's any issues, and I can just repost them again just to make sure. So let's go ahead and open up those slides. Once you have that link open, you can just use the arrow keys to move left and right to follow along with me. All right, so let's get going. Shiny for Python. So before we talk about the Python aspect of it, let's just talk about what is Shiny. I'll probably take a guess that most folks on the line have heard of Shiny before, but just to make sure we're all on the same page. Shiny is an open source package that was built within R to build interactive web applications. It enables you to do some really powerful stuff, customize the layout, style of your applications, dynamically respond to events, so the idea of reactivity, such as pushing buttons or sliding bars. There's a lot of cool stuff you can do with Shiny. And I always like to say that if you can dream it in R, you can build it in Shiny, because really the sky's the limit in terms of what kind of applications you can build using Shiny for R. So what is Shiny for Python? Well, it's exactly what I just said, but for Python. Now, before we start diving into the real content of today's workshop, I just want to make sure everyone's aware that Shiny for Python, this new framework for creating applications using Python instead of R, this is currently in alpha. So our team's been working on this for years at this point, but we only just announced it at our conference, which was at the end of July this year. So it's really now just starting to get some more testing within the community. We're getting a lot of great feedback, but just know that there could be some things that could change. You know, the API may change. So it's really not a good idea to put anything into production for Shiny for Python. But we expect, over the next couple of months to really iron out any bugs so that this is ready for your production applications. Now, when I was thinking of this workshop and how we wanted to kick things off, we could always spend the first 20 minutes talking about what goes into a Python Shiny application. But really what I thought would just be more helpful is if we just swan dive into it. And let's just create a Shiny for Python application right out of the gate. So the best part about Shiny for Python, and what you'll soon see here, is that you don't need to install anything. You don't have to have R, Python, RStudio Workbench, anything like that installed on your computer. If you're in this workshop right now, you'll be able to create and host and run a Shiny for Python application. And that is with the help of a really fantastic tool called Shiny Live. So again, if you have these slides open, you can feel free to click on any of these links. So let me open this up in a new tab here and just talk about a little bit about Shiny Live, what it is and why it's so powerful. So in a traditional sense, when you have an application like Shiny, let's say for R, for example, in a traditional Shiny deployment, you would have that application hosted on some server, right? Some Linux server, and then users would log into that server and then execute the code, the application from the server. But Shiny Live, it's a combination of the Shiny framework for Python in combination with something known as WebAssembly. And what this basically does is remove the server component of the computation. So there may be some static files hosted on the server, but for the most part, all the computation is now on the host's browser. All right, so every single user that logs into this application all of that Python code, the application is running within that user's browser. And so that is the power of Shiny plus WebAssembly, which we're going to call Shiny Live, which is going to be kind of our workshop environment for today. So if you want to get going here with Shiny Live, on this next bullet point, I have a blank Python session. So what I'm going to do is I'm going to open this link in a new tab. I'm actually going to stop sharing quickly so I can share my entire desktop. All right, and then I'm going to slide this editor over here to the right-hand side. All right, now if you are, this is kind of the orientation I'd like folks to have their screen set up, if possible, where you have the slides on the left-hand side, and then you have an instance of Shiny Live hosted over here on the right-hand side. All right, so this will be kind of the preferable way to get the most out of this presentation. So here is an active Shiny Live session. Now, Shiny for Python, you can see at the top. And the bottom left segment down here, this is an active Python prompt, basically. And you can write some really complicated Python code, such as 2 + 2 = 4. So it actually works. This is Python. We're running it in our browser, which is really cool. On the top left here, we have an app.py file that's completely blank. And then when we create an application and render it, it'll show up over here on the right-hand side. So let's just go ahead and get going. Now, what I would say for folks to have these slides open on your desktop, I'd rather you not copy and paste and actually try typing it out, because you're going to see there's some really important features about actually typing the code with the Shiny Live interpreter over here. So for step one, for creating a Shiny for Python application, we first need to import all the functions, which is represented by this asterisk, from the Shiny package in Python. So I'm going to come over here to this app.py file, and please feel free to follow along with me. And we're going to say from Shiny import everything, represented by that asterisk, the star. Okay, so that is step one, just loading all the functions within the package. Now, step two, hopefully will be familiar to folks that are comfortable with Shiny for R. And we have to add 3 components to this application. We have to add a UI, or a user interface, a server, and an app object. So a little bit about these 3 components. Shiny applications typically consist of 2 main components. That's going to be the user interface. This is what you see, what you touch when that application is running. And then all of the logic kind of behind the scenes of your application, all the math, all the code, that's all going to be housed within the server function. Now you take these 2 things, you take your user interface and your server, and you combine them into what's known as a Shiny app object. All right, so let's go ahead and do that. So coming back to our Shiny Live interpreter over here on the right-hand side, I'm going to basically just type out exactly what you see here, and we'll kind of talk about things as we go through it. So I'm first going to add a comment to myself. So anything that has that hash at the very beginning won't be executed. These are just comments to yourself. And I'll say this is the UI. No, it's a little divider here. And then we're going to first write some code for our user interface. So we're going to call our user interface app_UI. It's a pretty intuitive name. You can call it whatever you want. And we're going to basically set this equal to UI.pageFluid. Right, you can also see when we do this interpreter, when we start typing, we do get some tab completion, which is really nice. So once you see that little pop-up, you can actually hit tab, and it'll finish the function for you. Now, I wouldn't worry too much about what's going on here right now. We're just basically typing out exactly what we see here. But for the most part, we're just basically giving this a blank slate. It's like a piece of paper for the most part for this application to run. So that's the user interface. And now we have to add our server function. And here we're going to define a server function which has 3 arguments: input, output, and session. And that's it. We're not going to focus too much on what these individual components do. Just know that with the server function, it has these 3 arguments. All right, I'm going to add a colon here to the end and hit enter. We get that kind of auto indentation, which is really nice. Now, again, this is where you would typically put all of the meat behind your code or your application. We're going to leave this blank, so we're just going to put in a placeholder. And that placeholder can be 3 dots. And that's it. And then the last thing we're going to do is combine the server and the user interface into one thing, and that's called an app object. So this is basically the part of the app to tell Shiny to actually run it. So we're going to call this app. Now, this is really important because for Shiny for Python applications, you need to create an app object, and it has to be called app. All right, so make sure you type out app equals the function app. And then we just combine those two components. We have our user interface, which we call app UI, and our server function, and that's it. So this can more or less be considered the scaffolding for your Shiny for Python application. So when you have all the code written for your Python application, you can actually run it by hitting this little play button here in the top middle. If you're on a Mac, you can do the that symbol, shift and enter, and to run it and do that. And once you do that, you can see there's actually nothing's showing up. And that's because we haven't added anything to this application. We just provided the scaffolding. And so what we're going to do in our next step is something a little bit more interesting and add a component to our user interface. So this is step 3. And for this example, we're going to add a slider. So what we're going to do, you can see here on line 5, we have this new line of code. We're going to go ahead and type this out into the application over here on the right. So go ahead and place your cursor right there in the middle of the parentheses for that page fluid function and hit enter. And then type out exactly like what you see on the left. All right, so we have UI.input _slider. And once you see that tab completion, you can hit tab. And you're also going to get some options. So you get a little pop-up menu to kind of help you so you don't have to constantly remember all of the various arguments. So the first thing we need to add is an ID. So let's just give it a name of lowercase n. It's an ID. The next thing is going to be the label. We'll make it a capital N. And then we have to set a minimum and maximum value for the slider bars. So we'll say the minimum value is 0, the max is 100, and then we need a default value. So when you first open up this application, what's that value going to be set to? And we'll just set it to 40, but you can make it whatever number you want. All right, so this is exciting. We've now added something to our user interface. So go ahead and run this application by, again, clicking this little play button. And now we actually see something. All right, here is our slider bar. You can see it's set to 40 by default. I can move it all the way to the left. I can move it all to the right. I can play around with this all day. All right, something that we can see, something that we can touch. Again, this is going to be defined in our user interface. But this application is not really doing anything interesting. I can slide this bar left and right all day, but I'm not accomplishing anything. So once I set this bar to a certain number, it can be 36, I can go up to 76. We want to do something interesting with this number. So maybe we'll want to, add some value to it or multiply it or divide it. All that information, basically all the code running behind the scenes, is going to be within the server portion, right? And we call this server logic. So for this example application, we're simply going to take that number in our slider bar, which we've called n, and we're just going to multiply it by 2. That's it, right? Really simple logic. You can see down here in this code, we're going to be adding some lines into our server function. So we're going to basically write out exactly what we see here on lines 10 to 13. So coming over here to my Shiny Live interpreter, I'm going to remove that placeholder. So go ahead and remove those 3 dots. Now, there's going to be a bunch of stuff here I'm going to type out. Don't worry about it right now. We're going to focus on the server function a little bit later, but just go ahead and type out exactly what you see over here on the left-hand side. And I'll type it out and I'll kind of explain a little bit what's going on here. So we're going to define an output. And we're also going to be rendering some text. So we're going to use render.text. And now we're going to define a new function. All right, so we're going to define, that's a DEF, a new function that we can call whatever we want, but I'm going to call it text, all right, because we're going to be returning some text. So you want to make sure it's intuitive. So I'll say txt, open, close parentheses, and add a colon, hit enter, get that auto indent. And this is where you add your logic. So we're going to return a string. So let's return. I'm going to put a little F here and then a open and close quotations. And then just go ahead and type out exactly what you see here. So it's going to be n times 2 is, and then you're going to open up some curly brackets. And in those curly brackets, we're going to put input.n, open close parentheses. Again, don't worry too much about what's going on right now, and multiply that by 2. And that's it. That's our server logic. Pretty much everything you see right here in these curly brackets, this is all the math that's going on behind the scenes. We're taking that input value, you can see like up here, like 76, and multiplying it by 2. Now, if I rerun this application, well, I still just see the slider bar, and that's it. All right, and that's because we haven't taken this string that we've created and sent it back to the user interface so we can actually see it. And that's going to be the last step here, where we're going to add a text output. So right here on your slider bar, I can put my cursor right there, add a comma, and hit enter. And we're going to add an output. So UI.output underscore text verbatim. And then this is important. You have to make sure that the text you add here, so txt, matches the function that you created down here. So this txt matches that txt. And once those two align, that basically means that we're returning everything that's being returned from this function gets sent back up here and recognized in this output statement. You can hit play. And now we have something that's interesting. All right, 40 times 2 is 80. I can slide this to the right, and you can see how my application now reacts to input changes. All right, so I move to the left, move to the right, and this is cool. All right, we've now created a Shiny for Python application. All right, workshop's over. Congrats, everybody. Just kidding. We're going to spend a little bit more time talking about all the various components, but it's really important that this application we just created, make sure you keep it open because we're going to refer to it a lot. It's going to be kind of our go-to application for this workshop. All right, so let's first focus in on the user interface. And there's going to be two components to user interface. There's inputs and there's outputs. And the user interface, again, is everything that you see, everything that you touch. So if I go over here to my application, I have a slider bar, I have some output that I can see. All right, so everything here is being defined by our user interface. We're first going to focus in on inputs. So all input UI objects, like that slider bar we just created, have the same first two string arguments. The first one is going to be an ID. And this ID, we're going to focus in a little bit more later, but basically the ID allows you to feed values from that user input into the server. All right, so for example, if the ID of whatever input you just created is x1, you would refer to that input value in the server as input.x1 open close parentheses. And if we look over here with our application, our ID we gave this slider is lowercase n. And any value being returned by the slider bar, so 38, for example, 71, for example, is basically fed into the server right down here. Input dot, and this n matches this n. So that's the ID portion. And then you have the label. Label can be whatever you want. It's just the text that appears next to the input. So we had a capital N. If you want to make it a little bit more interesting, you can say like my slider, rerun the application, and I can see how that's being reflected in the output. So I have a link here to all the various inputs that you can have in your user interface with Shiny for Python. There is a ton of them. And what we're going to do is I'm going to quickly go through the next few slides and highlight some of the more common UI objects that are typically used for Shiny applications in Python, but also for R. So for those that have used Shiny in R before, some of these will look a little bit familiar. So I'm going to go blow through these pretty quickly and then actually have an application that basically houses all of these. Let me just move some Zoom stuff around here. All right. So the first one is a checkbox input. Then we have various ways to create numeric inputs. You can have a simple number where you can basically write in any value you want, or you can have an input slider, like exactly like we have up here. Moving forward, you have various text inputs. You can have a single box. You can have a text area where you can kind of expand the area. You can also input passwords. We have selection inputs, so you can select from a drop-down menu, a checkbox group where you can select one or multiple, radio buttons where you can select one or the other. Oops. And then we also have date inputs where you can select a single date or a date range. So in the next slide, I have a link here to an application that I created that basically has all of these various inputs. And that's going to be shown over here on the right-hand side once it renders. All right, so to quickly run through the same inputs I just talked about, and you can actually see them listed right here. One thing to note about this Shiny for Python application, notice that there is a user interface, but there's actually no server. And that's okay. If your application is not going to do anything, you can also put none right here in your server portion when you create that app object. But here's all those inputs I just talked about, and you can see them rendered over here. So we have our checkboxes, we have numeric inputs where you can go up and down, the slider bar we already saw. Here's our various text options. So you have a single box. You also have a text area where you can expand this box. And then you have passwords where all the text is basically hidden. And then we have various selecting options. So you can select from a dropdown. You can select a checkbox group, which means you can select one or multiple. Radio buttons, select one or the other. And then really handy option, date input. You can select a single date, or you can select a date range as well. So these are just some of the more common inputs you would see within applications, again, within Python, but also for R as well. All right, so that is a little bit about inputs. Really, the sky's the limit in terms of what you're trying to design for your application. Typically, there's going to be an input that meets your needs. So once you have this input, so for example, like the slider bar that we created, this returns some value. That value gets sent into the server, again, using this syntax down here, and it's going to do something, all right? Whether that be multiply it by 2, or maybe it does some more complex stuff. And eventually we want to take the result of that and send it back to the user interface, and that's going to be in the form of outputs. So just like inputs, there's a variety of different outputs you can choose from. Just again, as a quick recap, these UI outputs, they create a spot on the web page to put the results from the server. And there's only one argument required, and that's going to be the ID argument, which corresponds to the server's output ID. So looking at the slides over here, if this is your output that you have in your user interface, and you give it the ID of my text, this my text has to match an output that you've created in the server with the same name. Right? So my text function right here matches exactly what we see up here. That's how basically you can feed stuff from the server back into the user interface. Okay, so we have our first assignment here. So we are going to take what we now know about inputs and outputs, and we're going to fix this application. All right, so again, hopefully everyone has this slide open. If you don't, let me just quickly reshare this exact slide. And if you click on this link, so let me click on it, I'm going to slide it over here to the right. You should see something that looks like this. Now, to quickly orient folks, you can see here at line 5, this is where we defined our user interface, and then our server is down here in line 13. And basically what I want you to do is match all these various outputs to their corresponding inputs. So you'll see these in quotes, these underscores. I want you to replace these underscores with their correct output. All right, so let's take 3 minutes. I'm actually going to stop sharing. I'm going to reshare with sound because it's really important that I have sound. I really hope everyone heard that. Okay, excellent. All right, well, it seems like most folks are having luck here and getting this up and running, but let's go ahead and just do this together. Where are the fireworks? Yes, sorry. Maybe next time. All right, so here's our objective. We have all these underscores. We need to fill these with their corresponding outputs you see down in our server. So this first one is an output text. Let's go ahead and match it with this function we created down here, some text. I'm just going to copy it, paste it right in there. We have another one, some text verb, which is shorthand for verbatim. So I'm just going to copy that, put it up here. You can kind of get a theme here, a data frame, pop that up here. Got a few more, so we're going to put a plot in here. And it's also worth noting, we're going to dive a little bit more into it, but you can see how these kind of the at output and at render text, render table, render plot. So they tend to differ a little bit, but we'll talk a little bit more about that here in a second. And then we have some HTML. We'll pop that in there. And once you replace all those, we'll hit play. Let's take a look at this fun application. All right, so here's some cool things you can create in terms of outputs for your applications built in Shiny. We have our normal text up here. You can see now the difference between normal text and text verbatim. The verbatim kind of has like a code-looking interface. Here you can see a basic table. It actually looks pretty nice. We have a plot here being rendered using matplotlib, which is a really common Python package for data visualization. And then we get a little more interesting with this little marquee that kind of flies across the screen. So I'm showing you some other ways that you can create cool outputs. All right, cool. Awesome job, folks. Let's move on over to the next slide. That pretty much wraps up the user interface. We'll continue to talk about other components as well, but we're going to switch gears into the server portion. All right, so all the, the gears again, all the code that's basically running behind the scenes for your application is going to be housed within the server portion of your application. So we have this server function, and we have something known as server logic. So the server logic, again, all the code, is going to be defined within a function which takes 3 arguments. All right, so again, we're not going to focus in on what these 3 things do for this workshop. This is something if you want to take a little bit more time to understand what these 3 things are. But we have our, and just confirm, can you guys hear me okay? I'm not sure if there's give me a thumbs up if my voice is coming through a little distorted here.
Yeah, we can hear you. Don't
Okay,
worry.
all right. I'll try to talk a little bit slower too and not move my face around too much. All right, so we have an input, we have an output, and we have session. So when you create that server function like so, just know that there's going to be 3 arguments that you place in here: input, output, session. And that's pretty much it. All right, now for the server function, this is where you put, again, all of the logic for your application. And within that server, this is where you're going to access and use the various inputs. So inputs for this application. So again, we have a slider bar up here. This is the only input in our application. And we give it the ID of this lowercase n, and we access this input using input.n open close parentheses. All right, so again, that is how you access the inputs within the server. And this is also where you define the outputs. All right, so all the text I'm highlighting right here, this is basically defining an output, which is all within the server function. So to spend a little bit more time, okay, so yeah, just let me know if my voice isn't coming through clear at all, and I'll try to switch audios, but it seems like it's working okay for most.
Sounds great for me.
Okay, cool.
Yeah, Sam,
Yep.
it's good for me as well.
Awesome, good to hear. All right, so input values again are accessed using that input.x or .id, I should say. So that x can be the ID of the input. And I just really want to drive this home because it is an important component of what we call the reactive flow. And this is going to be the same if you're building Shiny applications for R or Python. So this, what I'm showing right here in the slides, this is the exact application you're seeing over here on the right-hand side. Now, when a user accesses your application and they move that slider left and right, that's going to be resulting in an input change to the slider bar. All right, and so that's going to be represented right here with this lowercase n. This input change is fed into the server and recognized right here. All right, so if you slide this bar to the left and it's 7, basically what you see in this yellow shading gets updated to 7, and everything gets rerun. All right, so this is the idea of reactivity, which we'll talk a little bit more later. But basically, everything reacts to this change. It reruns this code, and we're getting this string that we're eventually going to return back to the user interface in the form of an output. All right, so that's the general reactive flow. And this is continues to go around and around and around in circles for as long as the user continues to slide that bar left and right. So I did make a lot of parallels to Shiny within R. And so I wanted to actually call those out right now. So Shiny for Python, to access inputs from the server, you do that using this syntax of input dot, and then you give it the ID. All right, so I'll just put X here. It can be whatever ID you call it, open close parentheses. Within R, it looks something like this. You have input, $, and then that same ID. All right, so again, if you're more comfortable using Shiny within R, then hopefully now you can make some parallels between using Shiny for Python. All right, so let's talk about actually defining these outputs. And this is a really important part of developing really cool applications using Python. So we need to define an output. It's going to be a 3-step process. So this 3-step process, I'm basically highlighting right here, the 3 steps to create what I'm showing right here in this highlighted text. The first one is to create a function with no parameters. So for this example, we're just going to define a function, and you can call it whatever you want, but it's typically best practice to call it something intuitive. If this output is going to be some text, then yeah, text is a great name for this function. If it's going to return a scatter plot, then maybe you want to call it like scat plot or something like that. Just make sure it's intuitive. That's always helpful for just debugging codes later and trying to figure out what's going on. So this is step 1. Just define a function, call it whatever you want, put a colon here, and that's it. The next is you need to apply what's known as code decorators. All right, so we have to let the Shiny application know that we are in fact creating an output, something that's going to be sent back to the user interface. And then we need to say, well, what kind of output is it going to be? Is it going to be text? Is it going to be a plot? Is it going to be a table? So we have to also give it a render decorator as well. So for our example, you place these right above this function you just created. So again, we're letting Shiny for Python know that this is in fact an output, and it's going to be rendering some text. And then the last step is where you add all of the logic. And this could be really up to you and what your application is doing. So for this example application I'm showing here in the slides, what this application does is it reads in an input dot, and this input is going to have an ID of it enable. And if this equates to true, it's going to return some text saying yes. If it equates to false, or basically anything but true, it'll return to no. So now we know a little bit more about the server function. We got another assignment for you. Let me go ahead and we'll set that to 505. So I have 2 links here. This first link, this is what you're going to click on to actually do the assignment. But I also have a working version of the application. So let me actually just show you what this application looks like. It's pretty straightforward. So all it has is a single checkbox, and you can see when it's unchecked, it's returning some verbatim text that says no. But if I check it, it says yes. I uncheck it, it says no, and you can do that forever. All right, so that is the end product. So what I want everyone here to do, let's click on this first link, and let me go ahead and I'll just repaste the link to this slide. So you have it. So go ahead and click on this link, which I'm going to slide over here to the right-hand side of the screen. And similarly, you're going to see some underscores here. This is basically where I'm going to want you to replace with the correct text in order to get this application to work. All right, so I'm not going to say anything too much other than that. I'm going to go ahead and start this clock. Let's take 5 minutes. I want you to figure out if you can get this application to work. So spend some time looking at the user interface, spend some time taking a look at the server, and try to get this application to work. All right. All right, hopefully you don't get sick of that before the end of the 2 hours. So it looks like a lot of folks were getting it. If you didn't get it, that's totally okay. Let's actually run through it together quickly. Really, there's only going to be 2 spots that we need to plug in some values in order to get this application working. So let's just quickly review what we're looking at here. We have our user interface, which again, we're using this page fluid, which we'll talk about a little bit later. And we have an input, so we have a checkbox, which you can see is actually over here. So that's good. We have this H3. This is more or less a title. This is some HTML syntax, which allows you to just create some text in your applications like that. And then we have an output text verbatim, and we also need to fill in the ID there. If we look down in our server portion, we see we've defined an output. This is going to return some text or render some text. And we've called it txt. And so this is already something where we can plug in above in the user interface. All this output needs to get sent back to the user interface. We need to make sure we match that function ID. So txt will come up here, and we need to replace our output text verbatim with txt. And then if we look down here in the server, we have input.enable. All right, and so this is the ID that we're using down here in the server, and we have to make sure that this matches our input checkbox. So here, make sure spell it correctly, and also caps is important. So make sure it matches exactly how you've laid it out here. And now that those two match, and we try rerunning it, click it, and it looks like it's working just fine. All right, good job, everybody. Let's get back here into the slides. And let's talk a little bit more about reactivity. Reactivity is really what makes Shiny shine. The ability for you to make some tweak in your user input, and all the code reacts to that change to generate a new output. So for the application that we originally created, which I have here in the slides, but I also have over here on the right-hand side, just let's quickly review the reactivity flow for this application. So a user opens its application, has it rendered over here on the right-hand side, and they move the slider left and right. And I can do that over here, just like so. Every time we move that slider bar, that updates this value, this input slider, which we gave it the ID of n, and we feed in that value as an input, and we access that input using input dot and matching that ID. So this lowercase n has to match the lowercase n we defined in our input slider. Once we do that, all the code gets run, and this generates an output. It's going to be a text output, and we feed it back to the user interface, and we have to make sure that our output, the text right here, its function name, matches the output we define our user interface. So it's txt has to match the txt. And again, this just keeps going around and around and around in circles for as long as you continue to interact with this application. But then we had this question: what if my Shiny app does more than just multiply a value by 2? Really, all of the math within this application over here on the right-hand side is encapsulated within those curly brackets. And that's pretty much it. It's not a complex application, but as you start to develop more complex applications, you could imagine that you're probably doing some more complex things. So if that's ever the case, what's typically done is to create a separate reactive function. All right, and so this is some new syntax we're seeing here, where we're creating something known as a reactive calculation. Now, if we were to take this logic that we're highlighting right down here, where we just multiply the value from that slider bar times 2, and we're going to make this a separate react function, reactive calculation. So very similar to when we created an output function, which we have this defined text, we're going to do the exact same thing here. We're going to find a new function, and you want to call this something intuitive. Since all we're doing is multiplying the value by 2, we're going to call this function double x. Open close parentheses, we have that colon, and then you add all of your logic. Again, this is a very simple example, but you might imagine you might have 10, 15, 100, 1,000 lines of code that are all within this reactive calculation, everything being returned as this double x function. And once you've created that, rather than actually spelling out the logic within this string down here in our output, you can actually just plug in that reactive calculation. So this basically does the exact same thing we see over here on the right-hand side. So we have our output, we're rendering that text, we're going to call it text, return x times 2 is, and then we just feed it that reactive calculation we just created, that double x, and make sure you include those parentheses as well. Now, for those folks, again, that are very familiar with Shiny for R, this should hopefully look pretty familiar. To create these reactive calculations in Shiny for Python, again, you want to give it the code decorator reactive calc. If you were to do the same thing in R, you would use a reactive function, okay? So hopefully this will make a little bit more sense if you're comfortable using Shiny within the R ecosystem. All right, so with that quick primer on reactivity, we're going to do a quick assignment, and a 3-minute assignment. And there's going to be 2 objectives for this assignment. You're going to create a reactive calculation that does something. You can make it do whatever you want to the value n, and then you're going to add that reactive calculation function to the output. So let me quickly show you the application. Let's slide over here to the right-hand side of the screen. So starting on line 12, this is basically where you're going to create that reactive calculation. And then right below it, we can see our output. This is where you're going to plug in that reactive calculation. And you'll just have to kind of study the application and make sure you get all of the text correct. So let's go ahead and take 3 minutes and see if you can get this application working. All right, let's run through this example quickly. So we're really going to be focusing just on the server component of this application. Pretty much everything for the user interface has already been laid out for us. So I mentioned here on line 12, this is where we're going to create our first reactive calculation. So we have to give it that code decorator. So I'm going to remove that underscore. I'm going to add reactive.calc. All right. Now I've called this function endcalc. And all this function is going to do is basically whatever I want it to do. So I can have it do input.n, and maybe I'll have it multiplied by 1000. Right? Again, you can make it do whatever you want. You can divide it by some value, totally up to you. So this is our separate reactive calculation we just made. And then we can plug in this reactive calculation into the output. So rather than typing all of this out into the actual output, all we have to do here is write endcalc. That's it. And so when we rerun this application, now you can see 40 times 1000 is 40,000. And I can come all the way up here, get some big old values. And there we go. That's pretty much it. All right, let us move on to the next part. I just want to do a quick note about making some more parallels of Shiny to R. So I've already mentioned this parallel that this reactive function within R is basically the same thing as creating a reactive calculation in Python. For those that are proficient with Shiny and R, you also might be familiar with observe events, which are similar to reactive. You can also do observe similar actions within Shiny for Python using reactive.effect. And if you want to learn all more about Shiny for Python reactivity, something I should have highlighted probably earlier on, but there's a lot of great documentation on Shiny for Python. And again, with the ability to run applications within your browser, you can actually play around with it right within the documentation itself, which is a really powerful feature for this interface. All right, so we have a few more things to talk about. The next one is pretty exciting because we're really going to just discuss how you want to design your application. Like I mentioned in the very first slide, the sky's the limit. You can dream it in R, you can build it in Shiny, and you can build it in Shiny for Python as well. But typically, what's always going to be a question is how do I actually want to lay out my application, depending on what it's doing. It may be very simple. You might just have 2 rows, or maybe you're going to have multiple pages in your Shiny application. We're going to talk a little bit about how to do that. But to kick things off, I want to talk about a very common interface layout for applications within R and Python. And that's going to be a combination of this fluid page with a sidebar layout. So all the code you see over here on the left-hand side will create a layout, which you're seeing over here on the right-hand side. So if we just quickly run through this, at the very top, we see UI page fluid. All right, hopefully this looks familiar. This is exactly how we've designed our application over here on the right-hand side. The best way to think of page fluid is like a piece of paper. All right, when you define that page fluid function, you're basically saying, all right, here's a piece of paper, a blank slate for me to draw on. And you can make it one row after the other. You can have multiple columns, multiple rows. It's really up to you. So within that page fluid function, we're first going to add a panel title. So UI.panel title. Shiny within R and Python, we try as hard as possible to make these functions as intuitive as possible. So hopefully it's pretty intuitive that this will give you a title to your panel. And that's being reflected right here at the very top of your page. And then we define something called a UI layout sidebar. All right, so this is a type of layout. And you can see it's right here, this kind of big box. And within that sidebar layout, we have 2 panels. We have a sidebar panel, which is shown by this gray box, and then we have a main panel. So I'm only emphasizing this one because it tends to be a pretty common interface layout for Shiny applications. And here's an actual example. And I actually have a link to this application. So let me just open this one up quick so you can see an application that's leveraging this layout. All right, so while this loads, just quickly run through it here. We have our UI page fluid, right? We're giving it a title, which you can see is reflected up here at the very top. We're defining that layout sidebar. And that sidebar has two components. We have our sidebar panel, which is that grayed area right here. And then we have our main panel, which is everything off to the right of that sidebar. And within the sidebar, we have 4 inputs. We have a slider, numeric, another numeric, and a slider. And you can see that exactly laid out here. It's 2 sliders that are serving as a bread between this mean and standard deviation numeric sandwich. And then for our main panel, we just have a single plot. All right, that's being fed in from the server portion. You can see it's reflected right here. So again, pretty common layout for Shiny applications using that sidebar layout. But just know that this is not the only type of layout, and it's not the only type of page you can have for your Shiny applications. So page fluid, again, just tends to be the most flexible, the most commonly used, but there are a few other options like page fixed, which allows you to expand the width at certain predefined breakpoints. So if you want certain components to kind of fall underneath each other as your screen gets wider and narrower, that's an option for page fixed. Page nav, something we're going to talk about here in a second, it gives you the ability to add a navigation bar. Right? It also allows you to create Shiny for Python applications with multiple pages. And then if anyone's familiar with Bootstrap theming, Shiny for Python does support Bootstrap theming. And so you can create applications using that framework as well. Just a quick other note on some of the options you have for designing your applications. You could create an application which is just a series of rows and columns, and it's pretty easy to do so. So looking at all the code over here on the left-hand side, this application, so if you were to copy and paste this into Shiny Live, you would generate this application. So we have our UI page fluid, and we're giving this application 2 rows. You can see the first one right here and the second one here on line 10. Now each row has a maximum width of 12. Now, if you're familiar with Shiny for R, it's the same kind of syntax. Your width is basically the size of 12. So if you want to have a row be a little bit narrower and one be a little bit wider, you can basically set that first column to be 4 and the second column to be 8. And that's exactly what you're seeing right here in this top row. But if you want the 2 columns to be equidistant, or basically the same width, you can basically say this one's 6 and that one's 6. So, and you can have individual UI components in each one of these little blocks. Again, totally up to you and how you want to design your application. But this next component is really powerful, and that's the idea of using tabs and navigation. Because like I mentioned before, it basically allows you to create apps with multiple pages. So as your applications grow in complexity, you don't necessarily want everything smushed onto a single page. Often it's good to have, a little navigation bar so a user can go to a separate page on your application. So this is primarily accomplished using a kind of a suite of functions, UI navset _xxx, where this xxx can be a combination of a few different things. It can be tab card, pill card, and pill list. So what I want everyone to do here, let me drop this page into the chat so everyone has it. So on this page right here, go ahead and click on this app. And that's going to bring this example application. It's not very long, so it's only going to take 2 minutes probably to complete this one. So I'm actually going to start the clock here. But what I want you to do is replace the XXX, which you can see right here on line 4, with all of these. So try it out with just tab, then try tab card, pill card, pill list, and see how that changes the navigation bar in your application. So again, take 2 minutes to try this out. And again, this is also a great time if you need to take a quick break, stretch your legs a bit. All right, seeing some emojis pop up. You guys know the drill. Gotta wait for double zeros. All right, let's go ahead and do this one together. So again, all we're doing is we're going to place this XXX with, we'll start with tab. All right, and I'll hit run. Let's see what that looks like. All right, so pretty simple. You can see we have all of our tab A content. And then if you had a separate page, you can have all of your tab B content over here. If you want to make that tab look a little bit different, you can try tab card. So same exact kind of workflow here, but the look is a little bit different. That's going to be kind of the theme, that it does more or less the same thing, just changes how it looks. So let's try pill. All right, this one's a little bit cleaner. There's no lines. It just kind of highlights the A and B with a blue box. Or a pill. We can try pill card. Whoops. All right, same idea, but now it kind of puts it in this gray box. And then the last one we have here, pill list. And all options just for creating a multi-page application. All right, so that's just kind of the beginning here. But there's other navigation elements that you can incorporate into your navigation bar, basically. So you can also include external links, and you can do that using this UI nav control function, which I'll show you here in a second. And you can also create menus, which are extremely powerful. Basically allows you to click on, say, for example, like this A and B, but you would get a drop-down menu with various options that you can click. So let me show you what an example application looks like here. All right, so let's go ahead and let this render so we can see. All right, you can see this first one here. We have this UI nav A, and it's pretty much it. All of our A content right there under this tab. Now we have this UI nav control where I can add in an external link. So I'm going to go ahead and using RStudio, just kind of plug in the URL for RStudio. So if I click on this, it navigates me to the RStudio website. And then down here, we have this UI nav menu, all this text down here, which basically is rendering right here with other links where you get this drop-down menu. You can select to get all the B content, but you also have various other text that you can incorporate into your menu. All right, so again, extremely powerful as your applications start to grow in complexity, having multiple pages in your application. All right, so we are kind of at the end of what I'm going to be presenting. There's still plenty that we're going to talk about here. But just as like a quick wrap up, we really only just scratched the surface in terms of what goes into Shiny for Python and all the cool things that you can do with Shiny for Python. So if this has been interesting, I highly encourage folks to check out the documentation because, like I mentioned before, Shiny for Python, the ability to run these applications in your browser means you can have documentation with an application right underneath it. So you can actually try it out as you read the documentation. So if you go to shiny.rstudio.com/py and go to get started, you have two options. You can install it on your computer or you can just learn right in the browser. So I'll click on the next page. And here's an example. All right, so we have like a quick overview statements about the user interface and the server, but then right underneath, this is an actual Shiny for Python application within the documentation. I can come in here instead of saying hello world, I can say hello our pharma and run it. And you can see just kind of how powerful that can be for kind of learning more about Shiny for Python. We have tons of content over here. And as we continue to take Shiny for Python out of alpha, we'll continue to add more documentation to make sure folks are getting the most out of it. But we do have a final project for everyone. This is going to be a little bit more complex, but it's really a choose your own path, so to speak. So the whole goal is going to be kind of sticking with that same thing where I have created an application where you need to basically get it working. And you have three options. Now, again, if this has been making sense for you, if you're familiar with R for Shiny for R, then I'd highly encourage folks to try out getting this application to work with little help. If this is still pretty new to you, or maybe you're starting to grasp some of the concepts, you can use a little help. But if this is still not quite clicking just yet, that's totally fine. If you need a little bit more help, you can try starting with these links. So again, choose your own path. We're going to take 10 minutes to recreate this application, or basically to get this application working. So let me just show you what the end product looks like. Actually, I'll pop it up over here. All right, so you can see I have a numeric input where I can change the sample size, which is going to be creating a random distribution. And that can also change the number of bins from 13 all the way up to 50. I can also change the bin color from red to blue, back to red. All right, so this is the end product. This is what you're going to be creating. And again, let's take 10 minutes and start with one of these. Little help, some help, more help, and see if you can get this application running. If you do have any questions, I'll continue to be on the line. Go ahead and pop those into the chat, and hopefully we can get everyone rolling here. All right, let us quickly go over this. I'm actually going to pop up the more help option here so we can go through this quickly. It's actually been a little while since I've played around with this application, so you can see me get this working live here. All right, so knowing from the slides, I have my sidebar layout, and within my sidebar layout, I have 3 inputs. I have a numeric input, a slider input, and I also have some radio buttons down here. So here with this, my user interface, which is highlighting right here, first thing we need to do is replace this underscore with the panel title. All right, so I'll match what's in the image over here, random distribution. So I already have the UI layout sidebar defined. Here's my sidebar panel, so the grayed out area right here. I have a numeric input, so I'll just go ahead and give this a lowercase n. And it looks like I need to have a minimum, maximum, and a default value. So let's set the default value to 100, since that's what I'm showing over there. It does look like I have kind of a option for 10 to 1000. So I'll make the minimum 10, maximum 1000. All right, so that should take care of our numeric input. We have our slider next. So it's going to be changing the number of bins. So let me just go ahead. I'll call this one bins. Yeah, let's make it n bins. All right, so that should be good. And then input radio buttons, we need to give this an ID as well. This is changing the bar color. So I'm going to say bar color. All right, so again, trying to keep them as intuitive as possible. And then we have our UI output plot, where again, we need to plop in here the name of the function we're creating down in our server function. And you can see right here is I'm creating a plot. So let's go ahead and just match that. And then we have a few other underscores here that we need to replace. So this is a plot. We're creating a histogram. So I'm going to want to render a plot. And then plot histogram. Okay, so we have the random numbers of length, how long. And so this is basically where we need to come back over to our user interface and plug in some IDs. All right, so we need to choose our sample size, which we have as n. So I'll make sure to replace that as n. Our bins, this is going to be the number of bins. So we have n bins. Let me go ahead and match that. And then our last input, bar color. That's what we define down here. So input dot bar color. And that should be it. Let's see if I messed anything up. I'll hit play. And that appears to be okay. So I can try testing out a few things. If I set this to 10 and I try to go under 10, it doesn't work. Sorry, because I set my minimum. Same thing if I go to 999 and try to go above 1000, it doesn't work either. Number of bins, that looks okay. And I can change from red to blue. All right, so hopefully that was a little bit more of a challenge. But again, these slides will be available if you want to try it out. If you maybe tried it with option 3, maybe you can retry it with option 2. And then if you're feeling real confident, you can give option 1 a shot. All right, so a few last things to discuss. We'll probably end up finishing a little bit early. That's okay. So we're we're all done with the interactive component. So kudos to everyone here on the line that was able to run through Shiny Live and work through some of those examples. Feel free to keep playing around with it, build some cool stuff. If anything ever goes wrong, let us know. This is certainly things we want to capture to make sure that this is ready to rock for production. So one of the questions then becomes, and same thing with Shiny for R, is you've built something cool with Shiny. How do you share it? All right, there's a few different options for Shiny for Python. The first one, we are all very familiar with this at this point, is Shiny Live. If you have a simple application with minimal package dependencies, you can create it here within Shiny Live. And if for those folks that have already noticed, on the right-hand side is this little share button where you can copy this and you can share this Shiny Live application with the editor URL or kind of that finished application URL. So these are great ways to share very simple applications that you've built with your team, or maybe snippets of code that you're thinking about developing. Just know that when you share a URL from Shiny Live, pretty much the entire application is being compressed into the URL. So if I copy this URL and I paste it down here, you can see it's not the prettiest URL in the world. And if your application has lots of user inputs, lots of outputs, this URL is going to grow larger and larger and larger. You can use a URL shortener. So that's a great option if you have a real complex application hosted as Shiny Live. But just know that pretty much all the code to rerun this application is going to be housed within the URL itself. Now, if you have an application that's a little bit more complex and maybe has some custom built packages or some other packages that may not be supported by Shiny Live, which I've actually, this link right here shows all the current package dependencies supported by Shiny Live. We will continue to add more as we continue to develop this tool. But if you need some place to host your application, some of you may be familiar with this, shinyapps.io. This, for the longest time, has been a way to create a Shiny application in R, host it on our servers here at RStudio. So this is a hosted service, and basically just share a URL like you would any other website in order for users to access your application. But we were really happy to announce that you can actually use this with Python applications now. So if you do have an application, they want maybe one or two applications they want to share with just a handful of people, there is a free tier associated with shinyapps.io. So you can create a Shiny application, publish it to shinyapps.io, and share it with folks that way. And there's a few other options as well. If you need things like access controls, a little bit more compute power, there's a few other options. All right, and come back here. I do see there's one question in the chat here. I have a few more slides of one more quick little demo to show folks, and then we can take some time for some questions here at the end. Now, if you do have a Shiny application built for Python and you want to give it the full service, you can host it on something known as RStudio Connect. So for those that don't know what RStudio Connect is, this is a tool that we built here at RStudio, which is our publishing platform. So you can host Shiny applications in R, in Python. You can host other things as well, like our Markdown documents, Quarto documents, Jupyter notebooks, stuff in the Python world like Bokeh, Streamlit, Dash, lots of different content. But as of July of 2022, this year, you now have the ability to host Shiny for Python applications on RStudio Connect. Now, I know not everyone here on the line may not have access to RStudio Connect, but I do want to kind of walk through how you would go about creating a Shiny application outside of Shiny Live and hosting it on something like RStudio Connect. So I'm just going to quickly run through this demo using some of our tools in-house here at RStudio. And here I have all the steps for deploying a Shiny application. So I'm going to be doing this within RStudio Workbench. So I'm actually going to come over here. Now, RStudio Workbench is our server-based implementation of the RStudio IDE, as well as a few other IDEs. So you can use Jupyter Lab, Jupyter Notebook, the RStudio IDE, or you could use VS Code. Now, when it comes to Python development, for things like Shiny for Python applications, VS Code is typically going to be the go-to. All right, so I already spun up a VS Code session, so I'm going to open this up. All right, so if you're not familiar with VS Code, when I logged into this environment, I'm already in a directory. Shiny for Python is the directory I've created. It's just like creating a directory on the desktop of your computer. So I'm within that directory, and I had this app.py file open. All right, so this is a Shiny for Python application. It's a little bit more complex than anything we've seen, but this is a good example of something that may not work well because of maybe package dependencies or just the size of it within Shiny Live. So you may want to host it on something like shinyapps.io or RStudio Connect. So I'm going to open up a terminal session here. So a terminal is a way for me to interact with the command line interface. All right, and so I can do pwd to print my working directory. So that's just letting me know I am in fact within this Shiny for Python directory you can see over here in my Explorer. And so we're going to go through all the steps you see right here on the left-hand side to deploy this application to RStudio Connect. Now, it is worth noting that if you want to run it here within RStudio Workbench using VS Code, we do have a CLI, command line interface tool for Shiny for Python. So we can do Shiny, run, and I can just give it the name of the app, app.py, hit run. It actually spins up its own separate local web server, which is right here. I can click on this. And here's the actual rendered application. So this is a cool application. It uses something known as Leaflet, which some of you may be familiar with. It's a really powerful tool for, as you can see, creating maps. So you can scroll around. Looks like I'm in the city of London right now. And then we can use this input slider bar to control the zoom level. So I can zoom way out, or I can zoom all the way down to the ocean level, street level right down here. All right. So again, an application which may have some more dependencies, which may not work well with Shiny Live. How can we get this application hosted on RStudio Connect? So I'm just going to quickly go through these steps that you see down here over here on the left-hand side here within my terminal. So let me just go ahead and bring this up. The first thing we need to do is install RS Connect Python package. All right, so this is a tool that you can install using pip. All right, pip is our Python install package tool for installing Python packages. And this is a tool that we've built to help you, to assist you with deploying content to RStudio Connect. So we'll do pip install RS Connect Python. Now, this is something I've already done in this environment. So you can see requirement already satisfied. It looks like there's a new version of pip. We won't worry about that right now. All right, so step one, we are done. We've already installed this package. Next, you need to make sure that this instance of VS Code within RStudio Workbench can speak to RStudio Connect. This is something that you'll need to do beforehand because it will require the use of an API key, which you can generate within RStudio Connect. So I already previously did this, and you can see which RStudio Connect servers I'm currently connected to by running rs connect list. So this will list all the servers. So I've named this RSC production. And here's the actual URL to this RStudio Connect server. This is one of our demo servers here at RStudio, and you can see API key is saved. So that's just to make sure that this environment knows that it's me trying to publish this content to RStudio Connect. And the last thing you'll need to do, and this is something that some of you may be familiar with, but you need to create something known as a requirements.txt file. A requirements.txt file includes all the package information and the versions of the packages needed to replicate the environment as I have it right here in VS Code. So I need to basically create a snapshot of my environment and send that to RStudio Connect so RStudio Connect can recreate my environment. So you can create this requirements.txt file by running a command called pip freeze. All right, so if I don't forward this to the requirements.txt file and just hit enter, you can actually see what will be written to this requirements.txt file. So these are all the various packages I have in my environment, and you can see their corresponding versions. All right, so all this information is needed by RStudio Connect to replicate my environment. So what you would typically do is that same command, and you would pipe it over to a requirements.txt file and hit enter. All right, now this is something I've already done previously, so I'm not going to redo it. But once you've created that requirements.txt file, which you can see right here in my Explorer, we are now ready to deploy. Now, hopefully, some folks are familiar with the command line interface. This should not be a tool that you should be scared of. We try to make tools that it's not a huge barrier for using the CLI tool. And the RS Connect Python package, the CLI tool for deploying content, hopefully we try to make it as intuitive as possible. So this basically reads like a sentence. So I'm going to use the RS Connect package to deploy a Shiny application. Now, the period you see here means I'm going to deploy this application from my current directory. That's represented by the period. And now we need to tell the RS Connect package, where is this application? Or in other words, where is the entry point? And this is going to be an app. So we'll do app:/app and then enter. And that's pretty much it. RStudio Connect Workbench will take care of the rest. It's going to make this deployment bundle, send it to RStudio Connect. RStudio Connect is going to make sure it can read it, redeploy my environment. Now, I previously did this, so hopefully this will go pretty quick. Yep, so using cached environment. So that's another cool feature of RStudio Connect. And then we get some URLs. So let me go ahead and click on this URL. And now we are within RStudio Connect. And if we just give it a second, we'll have our Shiny for Python application running. So one more second. There we go. All right, and this Shiny for Python application behaves just like you had it running within Shiny Live, within locally on VS Code. I can scroll around here. I can zoom in left and right on the slider bar. All right, but the benefit of RStudio Connect is that you can easily share these applications that you've built. So as a publisher, I have control over access, and I've already made this open to the world. All right, so I can, anyone that has this URL you see at the top here, you can also create customized URLs. So I can say Shiny for Python down here and hit save. Oops, sorry, I have one there. So let's do Shiny _ for _ Python and hit save. And I can copy this URL, and just like you would share any other website, I'm going to go here into the chat. Everyone in the meeting, I'll just share this application so all of you can interact with it. And there's a lot of other cool features of Connect, like being able to tweak kind of the computational power supporting these applications. You can organize it with tags, they can access databases, all that fun stuff. That's all using the power of RStudio Connect. But that's pretty much it. The only other thing I wanted to mention here, given the audience and given that we're right in the throes of R and Pharma, is just to kind of have folks think about, how could Shiny Live, Shiny for Python be leveraged for R and Pharma? One of the big hurdles that need to be jumped over for submission, say, to the FDA for anything, you have to make sure it's in a validated environment, that anyone can take your analyses, your applications, and run it in their own environment with the instructions that you provided. And so it's really interesting to think about the power of Shiny Live and the ability to run these applications within your browser and how easy it is to share applications. So again, I'm not going to dive too much into it, but it's just kind of a thought provoker to with this Shiny Live, and it's kind of like a sneak peek. This framework for running code within your browser is something that's coming to R, hopefully in the very near future. So definitely stay tuned for that. But that's pretty much it. Again, all of the slides that I've shared in the link a couple times, these will remain open. So feel free to revisit, re-click on those links, learn more about Python, Shiny for Python in this documentation. And with that, I'll be happy to take any questions.
Something that R was a little bit ahead of. And so it's really exciting for Shiny to support that capability. Looking forward to more changes and advancements as this takes shape. And thanks to everybody for coming. If you have any questions, Ryan can stick around and answer those, or if you want to pop them in the Zoom chat. And hopefully we see you at other workshops over the next 2 weeks. And then the conference will be coming up November 8th, 9th, and 10th.
Awesome.
All right.
So,
looks like you got one there, Ryan. So.
Yeah, I've got a few questions popping up. And I should give the disclaimer here that I've been an R developer for well over a decade now. Python is still something that's very new to me. And this technology of Shiny for Python is even newer. So if I don't have any of the answers to the questions you have, I'll be sure to record these and I'll try my best to follow up. I'd also encourage folks to send me any emails with your questions. My email is pretty easy to remember. It's literally my first name, followed by @rstudio.com. So if there's anything that I can't speak to today, certainly send me an email and hopefully we can follow up there. But let's take a look at some of these questions here. So being lazy to find, is there an easy way not to react with plot when we change the color? Okay. Nadir, I wonder if maybe you can explain a little bit more what you mean by this question.
That question I think popped up when we did the last exercise. Let me check who asked it. Sudhir?
Yeah, I'm not sure if
I don't see him anymore.
yeah. He's still on the call. He just might be muted. Oh, I guess here. Oh, we can just barely hear you. It's a little hard to hear.
Sorry, my name is Sudhir. Yeah.
Okay. Yep.
Sorry, we just had a small earthquake here. So, the West Coast. Now, my question was actually about. So we were changing that color, right, in the reactive.
Mm-hmm.
So obviously it's input, right? The red versus blue, basically.
Mm-hmm.
So can we control the randomization with when we change the color? Just maybe change the color, not the distribution, I guess.
So you basically, when you change the color, it changes the distribution.
Right. Yeah.
Yep. Yeah. That's probably not something within Shiny for Python per se, but there is this concept of when you do something like a random distribution. You know, every time you regenerate the code, it's going to create a new random distribution.
Right.
So there is this concept of setting seeds. I'm not sure if you're familiar with setting a seed.
Right.
You can do that within Python, but if you set a seed and you set it to some random number, as long as that seed remains the same every time you access it, then that normal distribution will always be the same distribution every time you recreate it.
Okay. Thanks. Check into the details.
Yeah, it's a great question. Sam asks, is there a PyShiny cheat sheet yet? I guarantee you that's coming, but I don't believe one is created just yet. Looks like Arati, will you please explain what is the purpose of session argument in the server function? Yep, so that's a great question. So if you remember from the server function, there's 3 arguments: the input, output, and the session. For a lot of those, they're just kind of a requirement in order for Shiny to kind of run properly under the hood. The session one in particular captures a lot more information about the actual user that's connected to the application. So it may record information like the user's username, for example, which can then be leveraged within the application itself. But I haven't dabbled too much with the session argument, but that's kind of my understanding of what it can be leveraged for. Very similar to R. It's actually the same 3 arguments you'll have within the server portion within R.
Yeah, thanks. Thank you so much.
That's a good question. Yeah, Kevin asked, can you access local data in Shiny Live? That is definitely something that needs to be considered for Shiny Live, is that everything that needs to be placed into that Shiny Live application has to be running within the browser, which is not necessarily the best place to be putting private data, for example, or extremely large data sets for that. Certainly, you could, upload some local files potentially, but I would say as a rule of thumb, if your application is going to be dependent on some type of local file, then Shiny Live might not be the best option for you. For Shiny Live.io, are there some external Python packages that aren't supported? It's a good question, Sam. I'll have to double check. So the Shiny Live framework itself is limited in terms of what packages can be imported into Shiny Live. For shinyapps.io, and actually, well, rereading your question, let me come over here really quick. I'm going to reshare my screen. All right, so this is one of the links I clicked on in the slides. So sharing your Shiny applications, add the package dependencies. And so these are all the installed packages that come with Shiny Live. So without you having to, manually install them anyways, these actually just come built in. So it's quite a few, and a lot of the more common ones that you'll see, like Matplotlib, for example, NumPy. But scrolling down, there are ways that you can test whether a package is available or not. So there's other options, and you can define a requirements.txt file. So some of you may have noticed that for some of the applications that we were using, next to that app.py file in Shiny Live, there was a requirement.txt file, which is where you can actually basically add in additional packages, if they work with Shiny Live. So this is certainly something that we're continuing to work to see if certain packages do work with Shiny Live, and you can define those within the requirements.txt file. But I would just recommend checking out, again, the Shiny Live page to get some more info on that stuff. Good question. Pre-processing data can be done in R and use Reactive package and use Python Shiny. Yeah, so that's a good question. So Reticulate is a really powerful way to leverage Python code within R. All right, so a lot of times folks will incorporate some Python code within their Shiny applications built in R using Reticulate. Now, sometimes that doesn't work for all folks. And so what Python for Shiny is truly a Python native framework. So you don't have to use Reticulate. So there are ways that you can pre-process your data using R and maybe, for example, save it to a pin, for example. And that pin can be incorporated into a Shiny for Python application. So there's certainly workflows that can be incorporated where the pre-processing is done in R, and that pre-processed data can then be incorporated into a Shiny for Python application. But for Python for Shiny, again, that is a truly native Python framework, so it won't be leveraging Reticulate. All right, got about 10 minutes left. Any other questions? All right. Well, thanks again, everybody. I would love any feedback, so feel free to shoot me an email if you liked it, if you think there's anything I can do different with these presentations. But hopefully you'll learn a little something, and excited for everyone to try it out.
Fantastic. We'll post the video on our Pharma YouTube channel probably in a few weeks' time. And with that, as everyone exits, let us know if hopefully you see the Zoom survey. If you don't, shoot us an email, and have a great afternoon, day, morning, wherever it is you are. And thanks for coming.